and we're going to keep expanding this idea of simplifying radicals. This time I'm going to walk you through simplifying when we have variables inside of our radical. So here we see x to the 6th. Notice I can write that out to be 6x's. But remember, our index is 2, which means I only need 2 of the same thing to come out. So this would be an x times an x, an x times an x, and x times of x. I have 3 pairs of x's. So when those pairs come out, I have 3 pairs that are coming out, giving me an x cubed outside. Y to the 9th, I really don't want to write out 9y's. I want to look for another way of doing this. This is where I go back to my rules of exponents. This would be the same thing as y to the 4th times y to the 4th times y. Because when I add these exponents, 4 and 4, 8, and one more gives me 9, I have 9y's. But now notice this is the same thing, y to the 4th times y to the 4th. That gives me a perfect square. So when it comes out, I have just y to the 4th. But that leaves this lonely y inside of my radical. So the simplified version of this would be x cubed y to the 4th times the square root of y. We can do the same thing over here. 20 is my coefficient. I'm going to break down 20. 20 is 2 times 10. I can keep breaking down farther. 2 times 2 times 5. 2 times 2 gives me a perfect square. That gets to come out of my radical. X squared, x times x, perfect square, comes out. Y to the 7th, rules of exponents tells me I have y cubed times y cubed times y, perfect square, gets to come out. So that leaves me 2xy cubed outside of my radical and 1y left in. So if we take a quick look back at what we've done so far, notice when I have an even number, half of it is what I have coming out. In other words, I'm dividing by 2. When I have an odd number, when I divide by 2, I would have 4 and a half. 4 of them come out. That one remainder remains inside. Divide by 2, I have 1 of them out. Divide by 2, 3 and a half. We see we have 3 out. 1 remainder remains inside. Something to think of.